All right, good morning again. 8.2. So, you had your homework. Hopefully you had a chance to go over your homework very briefly, see how you did on it. I'll be back Wednesday morning. We'll go over these two sections, make sure you know how to do them. All right, so second section we're going to do today is 8.2, which is tangents. Now, we've talked about secants. Secants is 2, touches it twice, so it goes all the way through the circle. We have chord that goes through, it has its endpoints on the circle. We talk about radiuses and diameters. So a tangent is a little bit different. A tangent, here's your definition. So can you look, if we looked at our drawing, would this be a tangent line? No, because there's how many times does it touch? It touches twice. We want it to touch just one time, so this bottom line would be a tangent line. That would be, the point of tangency is F. That's where it would be the point. Okay, so here's your definition, just in case we haven't covered this before. A tangent line is a line in the same plane, okay, as a circle that intersects a circle exactly one time. Okay, so notice this would not be a point tangent line, this would be. Okay, so our tangent line is DFG, and that's our line. Okay, so where does it intersect? At point F, that would be our point of tangency. Okay, all right, so we have a tangent line. So how many times does a tangent line touch? One time. Okay, so not twice, once. Secant touches twice, tangent line touches once. All right, our next definition. Tangent segment. Now, this is different. Tangent segment. Now, a segment is not just the point. Okay? It looks like this. A segment, it starts at the point of tangency, and it goes to the outside point out here. So, a tangent segment is a segment of a tangent line that contains the point of tangent. So, if it goes from here to there, it just has to extend from the point of tangency. So it has to start from there and goes out. It contains it, all right? So the tangent segment. Okay, so a lot of times you'll see, we'll talk about a tangent segment F, Q, H, and we're going to start talking about that briefly in a short time. But that's what that's a tangent segment. All right, so here we go. Here's our first theorem. It says this: if a line is tangent to the circle, then it is perpendicular to the radius that is drawn at the point of tangency. Okay? So, this is just something you just got to remember. Okay? Why are we dealing with it? It just deals with right triangles, right angles. Okay? So, if it's a tangent line, I will draw a radius. And if wherever that radius touches, it will form a right angle. Okay? Form a right angle. All right? Any questions? So, wherever I have a point of tangency, no matter where it is, wherever this point is, this is now going to be a right angle. Okay? It's just, that's a common thing you have to remember as we start talking about points of tangency. Okay? So, tangent line, it's tangent to the circle, and it's perpendicular to the radius drawn at the point of tangency. Okay? Next theorem. If a line in the plane of a circle is perpendicular to the radius at the point of the circle, then the line is a tangent circle. So, if this is, so 8.2.1 and 8.2.2 are opposites. So, think about it. The first time we said it was that if it's a tangent line, then it is perpendicular. So now what it's saying is if it's perpendicular, then it is a tangent line. All right? Okay, so that's important for you just to remember. All right? They're the opposite of each other. All right? Here's our example, first example. All right, so find the measure of each angle in the quadrilateral. A, B, C. If AB and AD are tangent segments. So, we know these are tangent segments. So, let's think about this. What do we know about this radius right here going right here? Anybody tell me? Well, we would know that that's going to be 90-degree angles. Good. So angle B and angle D are both going to be right angles. Okay? So we know that. So let's put that down, right? Okay, so we got those. Any questions? So now, this is 180 degrees, right? And these two together have to add up to 180 degrees. So what's 3x plus 4x? Somebody? So, I'm sorry. Sorry. 3x plus x. 4x, good. 4x equals 180. Why is that? Because we already have two angles being 90, right? So divide by 4, what do we get? X equals? 4 goes into that how many times? Everybody get it? 45, good. All right, so let's show the work. And they do it a little bit harder, but either way, it comes out the same thing. So now A is 45, and then what's this? 3 times 45 is 135. Okay? So these two theorems help you be able to solve this problem. All right? So next thing you need to know. If a given circle and a point in the exterior circle you can construct two tangents to that circle. So in other words, here's what it's saying. All it's saying is this. If I have, and we're not going to spend a long time on this, if I have a circle, okay, and a point, it's not on that circle, I can draw two lines that are going to be tangent. Why is that? Because I can draw two lines from there that are going to extend, that'll only touch it one time. Okay? So we're not talking about a very difficult thing, but it is something that you just have to remember. Alright? Alright, so let's skip forward. We're not going to take too much time doing this. Alright, now, what it says about these two tangents that are extending to this point. What we know is that these tangent segments, AX and BX, what we will know is this, that they are going to be congruent. Now look at this. If you look with me carefully, you see we have two triangles. Now remember, these two triangles, this triangle here is going to be a right triangle. Why? Because remember that point of radius, this radius and this radius are going to be perpendicular. So therefore, perpendicular line. So now we have two triangles that have perpendicular, that are right triangles. And what else do we know? We know these radii are congruent, and we know this is congruent. So what kind of triangles are they? They're congruent triangles. Congruent triangles mean these outside parts are going to be congruent. And that's what you're going to need in order to solve this kind of problem, what we're going to be going over. All right, we're going to skip ahead. We're not going to do the proof today. I'll do it when I get back. And then we'll leave it there. You'll do the first half of the homework, and then I should give you plenty of things to do in class. We'll cover the rest of this, the inscribed angles and circumscribed, and that when I come back. All right? Have a good day.